All right, so we want to talk through 2.2, number 21. And Jacob has promised us a solution. What'd you get, Jacob?
I got y equals the square root of x squared plus c.
Like this?
Yep,
Okay.
that should be it.
Okay. What's the problem?
So when I plug in my initial values of -4 for y and 3 for x, and
Oh,
then
I see the issue.
I square the -4, you should get 16, like positive 16, right?
Okay.
Okay. In the book, they keep the 16 negative.
Mm-hmm.
Oh, because it's an implicit plus or minus in front of the square root.
Yeah.
Because otherwise you couldn't get a -4 out of a square root, because the square root function can never produce a negative number.
Yeah. So
Okay.
right at this stage, we have run into a whoopsie. Right, because I traditionally take the positive branch of the square root function.
Oh,
So
you know what? I think I just realized. Oh, wait, no, never mind. Sorry. Continue.
so let me pull this back a little bit. Let's fiddle with the algebra here for just 1 second. So I think I have y. Let me maybe say that as y dy is minus x dx. Everybody with that for separating? I subtracted x to the other side, multiplied both sides by a dy. Then I want to integrate. So I'm going to get y squared over 2 is minus x squared over 2 plus c. Everybody on board with this? Okay. Now, at this point, where'd your minus sign go? Jacob. Tisk. Okay. At any rate, doesn't particularly matter because the problem still exists. So, at this point, if you are the person introducing the square root, you get to pick whether you're doing the positive square root or the negative square root. That is a personal choice, except when it's not. And the time when it's not is when you're given initial values. It is possible that you don't get to pick. So, in the case that I'm left with this thing, which is this guy right here, is an implicit solution. Right? You guys recognize that? If I fiddle around with this just a little bit.
Yeah, it's an
Like
implicit solution, but it's not it doesn't, you can't not convert it to an explicit solution.
You had how many negatives in that sentence?
3, I think? No, 2. You can convert it to an explicit solution.
Ish being the problem. Okay, so if I add x squared over 2 to that side, right, to the left, you get this thing. Is this starting to look familiar?
Yeah, that looks like Pythagorean theorem-ish.
Okay, if you multiply both sides by 2, you get this thing. Does this thing look familiar?
Mm-hmm.
What does this thing look like?
It's the equation of a circle.
Uh-huh. So that's what's up. Your equation, your solutions are circles.
So if you turn it explicit, you're only going to get half your equation.
Yep.
Yep.
Yeah, so if I want to know what C is, frankly, I'm going to start back here. Okay, I'm going to look at this stage before I did any algebra to it, although the algebra doesn't matter. I'm going to start with this side because I have a y squared on this side, and that feels the closest to an implicit solution to me.
I have a question about this specific type of problem.
Mm-hmm.
a little while back at problem 12, or not 12, it was an earlier one. It was an initial value problem. I think it was 11, and we didn't do it here.
Okay.
But I decided that I didn't really want to, because it involved a square root and a bunch of fractions and nasty crap. So I decided that when I was solving for my initial value, I didn't really want to deal with that.
Mm-hmm.
So I went back a couple of stages to the point where it was it should be algebraically equivalent, but it's in an easier form. It didn't involve any roots or anything. It was an implicit solution.
Yep.
Can you solve for your constant at any state, even in an implicit solution? Or do you have to get into an explicit solution to solve for your constant?
You can solve for it at any state. However, if you then take a square root or something, you need to check that you're getting the right piece.
Got it.
So
if you do any
case,
branching functions, you have to figure out which branch you're in.
Yep, exactly. So in this piece, I'm going to plug in y is -4 and x is 3. Right? That's really what my initial value is about. So when I plug those in, I'm going to get -4 squared over 2 is supposed to equal -9 over 2 plus a constant. So I think I have 8 is -9/2 plus c. Oops, I guess I should make that 16/2. So I'm going to get 25/2 is c. And plugging that in, I should end up with y squared over 2 is minus x squared over 2 plus 25/2. You guys all good with that? And I think I can pretty clearly multiply by 2 here. Should get y squared is minus x squared plus 25.
Yeah.
You might notice that if you fiddle this around, right, into my circle form, this is a circle of radius 5.
I was going to say, it looks familiar.
Mm-hmm. And now, if you're going to, let me, okay. So, I have here a circle. This circle is centered at 0, has a radius of 5. If I'm going to pick an implicit, if I'm going to solve this, right? So I'm going to say, so y is the square root of minus x squared plus 25. You guys see that? If I pick this way, which half of the circle is this thing?
Should be the top half, right?
Yep. Good. So that is the top half of the circle. Now, where was my initial condition?
It's in the negatives. Be the bottom half.
Oh, shit. You guys see that? So I was right here. This is correct.
Wait, the x is in the negative, but the y is in the positive.
So
no, sorry.
Other way
I read
around.
that wrong. Never mind.
X is 3, y is -4, right? So the x is 3 and the y is -4 is down here. So this is not correct. You guys with me? Because it doesn't meet my initial condition. Like, it satisfies the differential equation. If you differentiate this thing and then plug it back in, it'll work. It just doesn't go through the point 3, 4, or 3, -4. It goes through the point 3, +4. You guys all kind of with me on that?
Yep.
One way you could have solved this is you could have, instead of solving for y, you could have solved for x. And then it would have to be on which half of the circle?
Oh, the right half.
Good. It would have to be on the right half of the circle. It is probably best to leave it as an implicit solution here. In the case that you feel as though you must get an explicit solution, the correct explicit solution is y is negative the square root of negative x squared plus 25. You guys see that? It should be
Gotcha.
noted that this is not, I'm going to call this correct. In my mind, that is a lesser answer
Because
than
it's
the
incomplete.
solution. It is more useful. Computers are better at calculating explicit solutions than they are at calculating implicit solutions. But the implicit one contains more information. You guys see this? If I'm looking at a planetary orbit, for instance, it would be really nice for me to be able to predict the entire orbit instead of only being able to predict half of it and then trust that it's mirrored.
Gotcha.
You guys see that? All right. We have
last one is-
successfully managed to use up most of a day.
I had a quick question on 19. We don't have to do the entire problem, but I had a bit of a conceptual question on it.
Okay, so 19 is
It's another IVP.
so 19 is good. That's perfect, Joe. Way to go. I put it at the bottom and then I made it tiny when I misclicked. Okay, so 19 is this.
Yeah.
Okay, what's the?
I just went ahead and integrated it. Rearranged, separated the variables, integrated it, and I came out with y plus y squared equals x squared plus c.
Okay, yeah, seems legit.
I cannot see any possible way to solve for y. So does this mean I have to leave it as an implicit solution?
You can complete the square, my friend.
Oh, lovely. Okay. So when you're given a problem like this, they expect you to give an explicit solution, I'm assuming. Because my first instinct would be, oh, just leave it in this form and then, solve for C, be done with it.
Yeah, the book has a tendency to select a branch and give you an explicit solution. I have a tendency to not give a hoot.
Okay, because my question on this, the reason I said that it was kind of a conceptual one as opposed to as problem specific, is when we come across something like this where we have an explicit or an implicit solution, and it's possible to convert it to an implicit solution, but perhaps difficult or would result in something really messy that loses some data, what would you recommend we do? Leave it implicit and solve for the constant and then just call that the solution, or go through the rigmarole of converting it to implicit and then solve for the constant, or convert it to explicit?
Yeah, I would prefer that you leave it as an implicit solution. Certainly, you should solve for the constants implicitly and then check that they work if you've decided to go get an explicit solution.
Okay, so don't just solve for the constant in this form. Complete the square, convert it to explicit.
Yeah, the good news is that the vast majority of this concern about implicit, explicit solutions, that really does mostly disappear as we go forward.
That's
fortunate. It is largely in this section in the book that implicit solutions appear. So going forward, there won't be these choices that you have to make.
Okay, so
section,
gotcha.
Go ahead, Jacob.
Oh, I was just going to say, to add on to what Ethan was saying, this specific equation, if you solve it implicitly, you get the right number. If you solve it explicitly, you have the chance of getting the wrong number, as I just realized I did.
because of the whole branch selection thing.
Yeah.
So okay, so the general policy should be get an explicit solution or get an implicit solution, convert it to explicit, solve for the constant, and then substitute the constant back into the implicit solution and call that your final one.
Yeah. So if I was doing this one, like unprompted by today's discussions, right? Like if I just ran across this in the math lab or something,
Mhm.
My inclination would be to complete the square on this thing, right? So how do you complete the square on this?
Add,
You guys remember how to complete the square?
I do. I'm proud of that.
Okay, so I need to add a quarter on both sides.
Mhm.
And the cool thing about having this arbitrary constant here is that you don't have to add the quarter on the right.
Yep.
Arbitrary constants are weird. So you get y plus 1/2 squared is x squared plus c. And then I would be inclined to say that this is minus 1/2 plus or minus the square root of x squared plus c.
Yeah, that's what I would do.
And then when I plug in my values, right? So I'm going to say, all right, so I'm going to plug in y is 0.
So you get
And
1/2.
X is 2. So I'm going to get 0 is minus 1/2 plus or minus the square root of x squared. Oops. What was x?
2.
So this is 4 plus c. You guys see that? So I'm going to
Yeah.
get that it's 1/2 is plus or minus the square root of 4 plus c. Okay, so that means I need the positive branch.
Right. So if
Okay,
you
so
square
I'm
both sides, you
gonna
don't have to worry
say
about
the
it.
Positive one. You guys with me on that?
Yeah.
Okay, and then I'm going to finish solving for c here, which you guys can do, but we're out of time.
Okay, thanks, Joe.
So get c equals number, cram number, back in there. Good. Okay. Any other questions, clarifications, things? Okay.
What question number was that